Hello there, welcome to another problem session. I found this problem in an Indian JEE exam that illustrates a really nice set of concepts, and I think it's a good problem to master. All right, this goes with the other circuit problems I have previously posted. Right now I'm doing magnetism, but I was going through the magnetism. I found this problem. I thought maybe I will just actually include that in my video series. Okay, so what it is here is I know there are a lot of symbols here, and looks like the easiest path here is just to keep track of numerical things. So this one is given to be 25 because R0 is 50, and from here all the way here is 50, and this is only 72 over 100 centimeters per 100 centimeters. So this one is up to 70 centimeters. So this one can be thought of as 36 ohm, and this side can be thought of as 14 ohm. Okay, another thing that you probably need to know, what's a null point. Null point is when there is no current here between, there's no current in this I is equal to 0. There's no current going through the galvanometer. That's called null point, which means there is no current in this branch. There's no current. And if you look at if there was a current, say I here, then Ohm's law, so if you have some resistance R not 0 and there's some current I, then if this is say A and this is B, so VA minus VB equals to I times R. Then if this is 0 and this is not 0, that will means this will have to be 0. VA, it has to be VB. So this point, this side is same potential as this, and there is no resistance of this same potential as that. Let's label all the potential points same potential points. That's my, I also do that first. And so this on the other side, if you think about null point, all of this will be a same potential, but big, and this will all be the same potential. So I will call that B. All of this will be the same potential, as if it was just like one little point. Okay, and then we can see that this all will be one potential, and over there will be one potential, and then all this side will be another potential. So A, B, let's call this side C. Let's call this side, let's call this E, and let's call this D. So you can write equations now. One of the ways to do is because no current here, all of these guys having the same current, so current circulates over there. Let's call it common current I, and because there's a condition like this here, we can actually write down two loops, one loop here and maybe another loop here. So we're going to do two equations. One equation will be in a loop like this, another equation will be a loop like that. So let's look loop 1 and loop 2. Let's loop 1. I start from A. You know, one of these potential have to be 0. So we just say this guy is going to be 0. So I'm going to have a V of A equal to 0. Note that V of C is not equal to 0. V equal to 0 does not mean V of C equal to 0. So this is not 0. So we don't know what V of C is. Okay, so we start from A. So I'm going to start from A, and I go like this and go like this and come back. Okay, So A to E to C and then B and back to A. So that's going to be in that loop. The current I'm assuming is going in that direction, and I'm going in that direction. So minus I times R1, and then I'm jumping over this, so I'm adding E to it. And let me take a more brighter color. I times R1 plus E, and then I'm over here, and then I'm going through this in the same direction. I'm assuming the current is going in that direction. I'm going in the same direction. So I'm going to drop the voltage 36 times I, and I'm here, and I'm going in the opposite direction to the voltage, so minus E over 2, and I come back here, so it's 0. So this is my one equation. And then in the other one, I'm going to go a little bit in the opposite direction. You'll see why I'm going to go in that direction, because that's direction well, might as well go in the same direction. It can be confusing, right? Let's do this. Let's go in that same direction. This was going in that direction, in the same direction. So you start from here again. Now this I'm going to increase in voltage. So in that one is A to A. I'm going to have A to B. I'm going to go to A to B, and then B to D, and then D to A. And it's going to be very easy. I'm going to increase in voltage by E over 2, and I am going to the current is going in. If you look at the current is going in that direction, right? Current is going in outside current. The current in there, I'm assuming, is going that direction, and I'm going in that direction. So I'm going to drop 14 I1, and I go over here. I'm going in the same direction the current. So minus 25 I1, and that equal to 0. And this is my 2. And these two, I just need to find R1. One thing you notice is you can just divide by I everywhere and solve for R1. So R1 minus R1 plus E, these two together is E over 2, E over 2I, and then minus 36 equal to 0. So from here, all I need is E over I1, so E over I, or E over 2I, and not I1, E over 2I. 2I, E over 2I, divide by I everybody. So that's equal to minus 14 minus 25 equal to 0. So E over 2I is simply 39. So I put 39 over there, and bring this down the other side. So R1 is 39 minus 36 equals to 3 ohm. And that's the answer. So it's a pretty simple problem, but where things go wrong here is that people say this side is 0. This is where people make mistake, okay? They say this whole thing is 0 because I'm on the negative of this guy, and because I'm the negative of this guy, this side is also 0. So they set this equal to 0, and they set this equal to 0. You can set one of them to 0, not both of them to 0. That's what the main mistake people make in this problem. Other than that, this is pretty trivial. Okay. Now, if you like this kind of solutions that I'm posting, please hit the like button. Okay, hit the like button. Maybe you can check out my website and subscribe to this channel. Tell your friends. I'll be posting, I'm just going through the intro physics lectures, every now and then, maybe sometimes daily or sometimes twice. Sometimes I kind of go over a week I don't post anything, but I hope to post more regularly. And so you should come, and if you subscribe, maybe you get reminded. Okay, this is it. Take care. See you in another video. Bye.